We are Samkara, and this is from Shinto shrines and Buddhist temples to exquisite joinery and furniture and intricate wooden crafts, wood has always been integral to Japanese culture and daily life. Behind these beautiful uses of wood, however, lies a stark reality: deforestation and other environmental impacts that threaten the sustainability of our forests and ecosystems. Despite Japan's substantial 68% forest cover, the country heavily relies on imported wood. In 2021, data shows that the total demand for wood products in Japan was over 80 million cubic meters. However, 60% of this wood was imported. While Japan's nature remains in harmony, Indonesia, one of Japan's biggest wood importers, released 842 metric tons of CO2 due to deforestation in 2023. That amount of CO2 emissions is equivalent to 998 flights from Tokyo to New York. That's almost 14,000 hours in the air. Acknowledging the problem behind it, we started to look into more sustainable solutions or alternative ways for the wood industry. What if we could eliminate the need to import wood by growing our own in a lab? With extensive developments in tissue engineering to create lab-grown bones, organs, and meat, our focus is to explore the potential of growing wooden furniture in a lab. This innovative approach could transform the way we source materials, offering a sustainable alternative that preserves our natural forests while meeting the demands of modern life. A previous study conducted by MIT had a similar goal of making lab-grown wood using plant materials. Cultured plant cells, nutrients, and plant hormones are made into a gel solution for 3D printing onto a scaffold and incubated for 3 months to develop. The resulting plant material shows it's possible to modulate the culture environment and bioprinting of the plant materials to make them grow into desired shapes and forms. However, this complex method for creating furniture requires a proper lab setup, limiting the practicality of producing lab-grown wood on a larger scale. Therefore, we decided to go with a different approach, using paper as a scaffold for plant cell cultures to grow. The multiple qualities of paper allow it to be an effective framework to culture different types of cells. The use of folding, a fundamental principle of origami, would significantly reduce the amount of material needed compared to traditional furniture construction. Inspired by this, we folded the paper into 2 stable scaffolds on which plant cells can grow. The first is a crossed structure design that allows 2 identical modules to join together and form a rigid structure. The second is a bellow-folded structure that provides strong support using a single piece of paper and is easy to build without assembly. Our first attempt was to bleach the paper structures to remove fiber tissue and cultivate with pea sprouts within a nutrient solution containing vitalizing agents. However, the liquid culture environment's inherent flexibility resulted in the paper's unstable attachment to the pea sprout cells. Despite the rapid growth of the pea sprouts, their softness rendered them unsuitable for use as a material in furniture construction. Following consultations with experts, we modified our approach by adopting a gel medium as the growth environment. To ensure the stiffness of the furniture, we decided to simplify the lignification process from MIT research by using cells from bamboo shoots, which are not only highly accessible but are also high in lignification. Using hormones such as cytokinins and auxins can change the lignification levels of the Phyllosaceae nigra cells, which are found in bamboo, forming a secondary cell wall during the proliferation and lignification phases. After adjusting the chair design and procedure, we prepared the cellulose scaffold bases, utilizing sterilized paper. Following this, we assembled the required materials for the subsequent cell migration phase. These materials include plant hormones like cytokinins or auxins, rooting gel containing indole 3-butyric acid to facilitate faster cell migration, and the primary component, cells sourced from fresh bamboo shoots. The first step involved applying rooting gel evenly onto the origami paper structure using a brush. Next, small pieces of fresh bamboo shoots were grated and placed onto the gel-applied paper to ensure proper adherence for cell migration. The final phase included applying a plant growth nutrient spray containing cytokinins or auxins hormones onto the paper. Then, the entire structure was put into an airtight container to allow cell cultivation. By allowing us to cultivate bamboo cells into any desired shape using the origami cellulose scaffolding, this process opens the door for customizable and uniquely shaped furniture designs. As we look to the future, our vision for Sakae is to revolutionize the wood furniture industry by providing a sustainable alternative to traditional timber. By harnessing the power of lab-grown wood, we aim to reduce deforestation and create biodegradable wood products that meet the demands of Japanese industry. Our immediate priority is to refine our methods for cultivating bamboo cells on our origami cellulose scaffolds. Due to the lack of proper lab equipment and facilities, our initial experiments have not yet yielded recordable results. Therefore, we need to employ a fully equipped lab to properly test and refine our methods. Once we have optimized our methods, the next step is to evaluate the feasibility of scaling up production. Establishing pilot studies will help us understand the practical applications and potential challenges of producing lab-grown wood furniture on a larger scale. A key aspect of our future research will be to evaluate the durability and longevity of our lab-grown furniture. We need to conduct long-term studies to assess how well these products withstand environmental factors and daily use. Understanding these factors is crucial to ensuring that our products are not only sustainable, but also reliable and long-lasting. Our journey towards a sustainable future is just beginning. The long-term vision is to create a closed-loop system for sustainable furniture production, minimizing our carbon footprint and raising awareness about the environmental impact. With Sakae, we are committed to bring together environmental innovators, policymakers, and global investors to step forward into a more carbon-neutral world and preserve our planet for future generations.